So today we're checking a warm-up problem of a word problem, since that's what we were working on mainly yesterday. So the word problem says we're going to the mall to spend the $200. We discover, sorry about the typo there, that has all jeans for $25 and all dresses for $50, and you want to take home 6 items. So I know that if I'm spending money on jeans and dresses, that I'm going to take some number of jeans plus some number of dresses, and I want it to add up to 6. I know the cost of the jeans are going to be $25. The cost of the dresses will be $50. And I can't go past $200. So there's my 2 equations. We're going to solve this using substitution. You really wouldn't want to graph this. So we look for the easiest variable to get by itself, and that would either be this j or this d. It doesn't matter which one you pick. I'm going to pick the j just because of the fact it comes first. So that means I'm going to subtract d. So I'm going to rewrite the second equation to be j equals negative d plus 6. So now we take that and we replace the j in the second equation with it. So I have 25, take out j and replace it with negative d plus 6, and then write the rest of the equation. So now we need to distribute. So I have negative 25d plus 150, 25 times 6, plus 50d equals 200. Combine my like terms here since they're on the same side. We're going to add negative 25 and 50, which is a positive 25. And now we go minus 150. So 25d is equal to 50. Divide by 25. So the number of dresses would be 2. Well, if I bought 2 dresses and j plus dresses equals 6, that means I bought 4 pairs of jeans. Now, yes, I know you could have guessed and checked to find your answer, especially since it just was adding up to 6, but the goal here is to also write equations because that is just as important. Here are your homework answers from last night. Feel free again to pause and to look over the work as needed. Number 8, the answer is 1, negative 3. Number 12, going straight across, if you have 0 equals 3, that means it's no solution, so the lines would never intersect. They would be parallel. Number 9, the answer was 2, 7. Y is the better one to solve for in this case, and it doesn't matter which y. They're both the same. Number 13 on the right side, 4 equals 6 would be no solution. 14, here are your 2 equations. X plus y equals 14, and y equals 2 plus 2x, or 2x plus 2. And the answer was 4 pens and 10 books. Number 10, the answer was 1, negative 4, and number 11 was 6, 3. And then 15 on the right, y was your length, x was your width. On the next page, number 16, here are your 2 equations. K plus L equals 20, and that L equals 3K minus 2 for the 2 hours less than 3 times the number of hours Kim exercises. So Kim exercised for 5.5 hours, and Leon exercised for 14.5. 17, Drinks were $3 and popcorn was $5. 19, the easiest way to look at that problem would be to think about the fact that to have one solution, you have to know where they cross. And the easiest way to make them all have the same crossing point is to make their y-intercepts all the same. You could have done it other ways, but this would be the easiest way. So their slopes need to be different, and all their y-intercepts need to be the same, whatever number you happen to choose. And on 20, it's no solution, which means it would be two parallel lines. Pause as needed or rewind if needed, and check with each other to figure out the answers if you need to. So go ahead and work through the Explore activity, and then once you've worked through it and have checked with your partner, then go ahead and start unpausing this to go over it. Right, here we go. So with adding equations, hopefully you notice that the coefficients of the y terms were opposites. If you remember a term, if you've heard it before, opposites, which means they would add to 0, are called additive inverses. So the sum of negative 3y and 3, hopefully you know that that would be 0, and that's because they're opposites. So now they wanted you to add the equations together. Well, x plus 5x, that would have been 6x. The 3y's would have been 0. Please do not put 0y, just 0. And the negative 15 and negative 3 adds up to negative 18. Well, really and truly, we could have just canceled this out. So we would have had 6x equals negative 18 divided by 6, which means to find x would be negative 3. Well, we know that if we find one value, we can find the other by plugging it back in. So hopefully you chose the top one. So it would have been negative 3 for x minus 3y equals negative 15. Add 3. So we now have negative 3y equals negative 12 divided by negative 3. Y equals 4. So the solution for this is x equals negative 3, y equals 4. Your reflection questions, they said if you add 5x and 3y to x minus 3y and add negative 3 to negative 15, how do you know that the resulting sums are equal? Because you're just rewriting the equations. You're not changing the values. And then to check your solution in part E, well, you would plug x and y. Oops, sorry about that. Or substitute would probably be a better word. Into both equations. Or you could graph. So this is what we're going to be working on today, and then after Thanksgiving break, we're going to be adding a step to this. So the basic part is very important you understand. So when we solve a linear equation by adding or subtracting, it is mostly referred to as the elimination method. So this is our third method to solve a system of linear equations. We first learned graphing, then substitution, and now elimination, and this does tend to be students' favorite kind. So elimination means to get rid of something. So our goal is to eliminate one of the two variables by adding the two equations together. We're going to avoid subtraction, and we'll talk about what we do in that case, but we're going to be sticking with adding. So you're going to add or subtract the equations. You're going to combine them like you did in the explore activity, which in that case it eliminated the y's, and then you solve for the other variable. And then steps 2 and 3 are just like the other steps. You plug that one back in to find the opposite variable. So here in example 1, again, they've worked one out for you. If you notice, the two y's are opposites, which means when you add these two equations together, they're going to cancel out. Now they write a 0, we're literally just going to put a line through it. And we would just start with the 5x equals 20 line, which means x is equal to 4. So then you choose which equation looks easier. If you notice here, the bottom one looks easier than the top to plug it back into. So you replace the x with 4 and solve for y. So our solution is 4, 2, which means on a graph, the two lines would cross at one point, and that would be the point 4, 2. And again, that's what they did in step 4 to check it. Remember to also check it, you could plug it back into both equations to make sure it makes it true for both of them. So that's one worked out that you can go back to and refer to. We're going to actually work some out together because that's the easiest way to learn. Now their next example, part B, talks about subtraction. And again, we're not going to subtract. So we're going to skip part B, and I'll show you what to do on some actual practice problems. So this is the rest of part B worked out. Again, since there's a solution, it does mean that the two lines would cross on a graph. All of these refer to that visual picture of the graph. We're going to skip the reflection questions and go directly to working some out. So now we're on page 297. You might want a separate sheet of paper to work these out. It's up to you. There's not much room on here. So I'm going to write number 6 down here where I have some room to work on it. Now, if you notice about this equation, remember there are two other methods we could use to solve this, graphing and substitution. Graphing we could do, but we would have to solve for y, which would be a little complicated, and then you'd have to set up a graph and graph it and then look for where they intersect. Substitution, if I look here, is there a variable that you would want to get by itself? Well, all of them would involve multi-steps, so not really. So elimination, which is the method we're learning today, would be your best bet. With elimination, you're looking for two variables that are opposites, so they would cancel out. So if you notice, if I were to add these two equations together, the 5y's would disappear, so we're going to put a line through them. We now add the rest of the pieces together, so 2x plus 3x is 5x, negative 24 plus 14 is negative 10, divide by 5, x equals negative 2. Well, once we find x, we now have to go back and find y. So you can plug it into either equation. I'm going to go with the top one. So 2 times negative 2 plus 5y equals negative 24. So I have negative 4 plus 5y equals negative 24. Add 4. So 5y equals negative 20. Divide by 5. So y equals negative 4. So my solution for this one is negative 2, negative 4. I want you to go ahead and work on number 9. So skip 7 and 8 for right now and go down to number 9. And then check with the neighbor once you have an answer. And then unpause the video for us to go over number 9. So on number 9, if you notice this time, the y's are opposites. So that means when I add the other pieces together, the y's would cancel out. 3x plus negative 2x gave you 1x or just x. Negative 2 plus 3 gave you 1. So x equaled 1. Didn't even have to solve for it. So we plug that back in. I'm going to choose the bottom one. It shouldn't matter if you chose the top one. So it'd be negative 2 times 1 plus y equals 3. Well, negative 2 times 1, that's negative 2. Add 2 to both sides. So y equals 5. So this would be the ordered pair 1, 5. Hopefully you got that answer correct. So now let's go back up and look at number 7. So I'm going to rewrite number 7 down here. Now, on 6 and 9, it worked out that we had opposites. But if I look at my two equations here, 3x plus 3x would be 6x, and 2y plus negative y would be 1y. So none of them eliminate. Well, can you think of something, a pair that would be close to eliminating? And hopefully you recognize that it's close, it's possible to eliminate these. Now, the book calls it subtraction. We're going to still add, but think about it. If we add the opposite, then those would cancel out. So what we're going to do is we're going to change all the signs of the second equation. So it's kind of like we're multiplying it by negative 1. We're adding the opposite, which is what subtraction is. So now this time, the x's eliminate. 2y plus now a positive y is 3y. It's now 10 plus negative 22, which is negative 12. Divide by 3. So y would be equal to negative 4. Once we find y, we now need to go back to find x. Remember, you want to use one of the original equations. Don't pick one that you changed. So I'm going to go with the top one. So 3x plus 2 times negative 4 equals 10. So I now have 3x minus 8 equals 10. Add 8. 3x equals 18. Divide by 3. X equals 6. So for number 9, the solution is 6, negative 4. I'm sorry, for number 7. So when the variables are the same, we're going to change all the signs on the second equation. You could subtract, but usually what happens is students forget to subtract the last two, and they go back and add them. So if we change the signs at the beginning, where we changed each sign, then we won't forget how we need to combine any of them. So now I want you to go look at number 8. Go ahead, try number 8 on your own. Check with your neighbor once you get an answer, and then unpause this for us to go through it. All right, so you should have a solution to number 8, so let's go ahead and check it. I'm going to be scrolling all the way down here so I have some room to write on it. So the first equation in number 8 is 3x plus 2y equals 5. And the second equation, x plus 2y equals negative 1. So again, if none of them are opposites to start with, then we look for the one that's the same, so we can change signs, and the y's are the same. So I'm going to add the opposite here. So the x becomes negative, 2y becomes negative, and the negative 1 becomes positive. 3x plus negative 1x, that's a 2x. 2y's are gone. 5 plus 1 is 6. Divide by 2. So x equals 3. To find y, again, you can go back to either the original. I'm just going to choose the top here. So it's 3 times 3 plus 2y equals 5. 3 times 3 is 9. Subtract 9. So 2y equals negative 4. Divide by 2. So y equals negative 2. So your answer for number 8 should have been 3, negative 2. I'm going to scroll this back up to write the answer, so pause it if you need to check out any of this work. And that's the most important part about elimination. Now, just like graphing and substitution, we have our special systems. There are still 3 possibilities. One solution, which is what we just did, infinitely many, and no solution. And what happens is when you add the equations, just like in substitution, the variables cancel out, and you're either left with a true or a false statement. If your statement is true, which is what happens in A here, then it has infinitely many, which was the same as substitution. And then you could graph it to show that since it's infinitely many, it would be the same line, which means when you solve for y, the equations would end up being the same. Part B, you end up with the equation 0 equals negative 6. Well, that's a false statement, which means it's no solution. And hopefully at this point you can automatically visualize what the graph would look like. No solution would be 2 lines that never cross. We're going to ignore question number 10 because I want to actually practice a few of these problems together. So I want you to go ahead and start with number 12. We're going to jump to a different one. We're going to start with number 12. So go ahead and try that. Check with your neighbor what you think your answer should be, and then unpause this for us to go over it. So if you notice here, we do have opposites. So when I add these 2 equations together, well, x plus negative x will cancel. Negative 6y and 6y will cancel. Since they both cancel, that means I have a 0 here. On the right side, 7 plus negative 7 is also 0. So variables cancel. So now we're left with asking, is it a true statement or a false statement? 0 does equal 0. So anytime it's true, your answer should have been infinitely many. So now let's look at number 11, going back a little bit here. If you notice here, this time we don't have opposites, but our variables do have the same numbers, which means we're going to add the opposite here. So I'm going to put my plus sign and then change all the signs. So now 4x plus negative 4x, well, that cancels. Negative y plus a positive y also cancel. So again, since both canceled, we're left with 0. On the right side, we have 3 plus a positive 2 now, which is 5. Well, does 0 equal 5? The answer to that is no, that's false, so this means this one would be no solution. The last thing we need to look at is, just like all the other problems, word problems as well. The biggest thing here is with perimeter. Perimeter is a formula that you need to know of a rectangle. And the formula for the perimeter of a rectangle is 2L plus 2W equals P. You're going to see that one a lot show up with systems of equations. So make sure you know that, because a rectangle has two lengths that are the same and two widths that are the same. 2L plus 2W equals P. So with the best backyards problem, you'll notice it says the perimeter is 40, which means we take the P out and we put 40 in its place, which is what you see here. It then says the difference, which is subtraction, between twice the length and twice the width is 4. So here are your two equations. 2L plus 2W equals 40, and the 2L minus 2W equals 4. So we take those two equations, we look for our opposites, which in this case, hopefully you notice the widths are what's going to eliminate here. So here they eliminated. So we were left with 4L equals 44, which means you have a length of 11. And then you then plug it into either equation to find your width, which here it was 9. And again, you can always go back and look through these steps since this is in your workbook. So now let's actually do a problem together here. So we have Movies and More, their one-day sale on DVDs and video games. We can buy 3 DVDs and 2 video games for $74, or 5 DVDs and 2 video games for $98. Well, if I look at the first sentence here that talks about DVDs and videos, that's my first equation. So 3D for DVDs plus 2V for video games would equal $74. If you have 2 variables, then that means you have to write 2 equations. So we go to the next sentence, which says we have 5 DVDs and 2 video games, and we would spend $98. So here's my system. And again, it's not about guess and checking. It's about writing the equations for your proof for it. Well, if I look here, if I were to add these together, would anything eliminate? The answer to that is no, but there's a pair that are very close to each other, which are the V's. So because they're both positive 2V's, we know we need to make one the opposite. So the 5D becomes negative, the 2V becomes negative, and so does the 98. Now 3D plus negative 5D is negative 2D. The VD's cancel. And 74 minus 98 is negative 24. Divide by negative 2 to solve for D. So D equals 12. So we bought 12 DVDs. Now we need to find out how many video games. Again, you could plug it into either original equation. I'm just going to go at the top here. So it's going to be 3 times 12 plus 2 video games equals 74. 3 times 12 is 36. Minus 36. So 2 video games are 38. Divide by 2. So each video game was $19 and each DVD was $12. You're going to have some homework problems tonight and then practice in class tomorrow. And then you'll review all the sections on Thursday for your quiz on Friday.